Hi there and welcome to Memgraph webinar. Today you are going to learn how to get started with Memgraph and Python. Let's dive in. First, a bit about myself. So, my name is Katarina. I was born at the Croatian coast in the little town of Šibenik. I did my master's in mathematics and computer science from the Faculty of Science in Zagreb, and now I work as a developer relations engineer here at Memgraph. I like to travel, cook and eat tasty food. Okay, so first, let me tell you a bit about the graph data model. What are graphs and how to model a graph database? So, graph is a network structure that consists of a set of nodes and a set of relationships. You may notice that someone calls them vertices or edges or points or links, but this is actually just a different naming convention. Okay, so on the right, we have something that is called label property graph model. It's called that way because each node has a label, and a node or relationship can have properties. For example, here, a person is actually a label of a node. Also, city and locations are both labels of the nodes, so one node can have more than one label. And each relationship can have a type. So, for example, here, married to is a type of relationship. Also, lives in is a type of relationship. Here, nodes have properties. For example, person has properties name and date of birth, while city and location node has properties name and country. Relationship can also have properties. So, for example, relationship of type lives in has property duration in years. Okay, so now we learn about graphs in general. Let's head over to an example. So this is an example of Twitter graph data model. Here we have a user, so we have a node that is labeled with user, and we have a relationship of type retweeted. This relationship doesn't have any properties, but the node has a property and it's called username. Now, why would you even use a graph database? Maybe you are familiar with relational databases. Let me tell you a bit about the differences between these two. So, relational database usually has some kind of schema that it has to follow, but graph databases are schemaless. That gives you a bit more flexibility where you can have different set of nodes with different set of properties, so you can play with your data a bit more. You don't have to follow a certain schema. Another difference is that you have in relational databases a lot of tables, and this data is not connected in the beginning. So in order to connect that data, you have to do a lot of joins. This sometimes can get really complicated, especially when you have many-to-many relationships, like friends of a friends-like data set. But in graph databases, the data is already connected in the beginning. So each node holds an information to which other node it is connected to. And then the querying this data gets more simple because you don't have to join tables, you just have to traverse the whole graph. So I will give you an examples of when to use graph databases, and maybe then things make more sense. First, let me tell you how we communicate with Memgraph, our graph database. So we communicate with Cypher query language. This is the most widely adopted, fully specified open query language for property graph databases. There are other languages with which you can communicate with graph databases, but this one is most widely used, so we also use this language in Memgraph. Cypher language contains clauses such as match, delete, set, return. For example, match is something similar to select in SQL database. It contains functions such as round, string, and so on. But also in Memgraph, you can create custom procedures that are written in Python, C, C++, and Rust. This is awesome because you can extend the Cypher query language however you like. So if something is missing, you can just write it by yourself, especially if you are a Python developer. Then it gets pretty easy to deal with your data however you like. Okay, so what is exactly the difference between Cypher and SQL? So for example here, if you have something that is a graph use case, like some kind of product recommendation, then Cypher is much easier to use than SQL on a relational database. So here we have some kind of customer, and we want to find this customer inside the database that bought some product, and we want to then find other customers that also bought that same product, and we want to find a product that those other customers bought, and this will be some kind of recommendation for our first customer. But we want to find only recommendations that the first customer hasn't already bought. This is where not part. And then in the end, we want to return like the best recommendations, and these are the ones that have the best frequency, and that's why we are returning them ordered by that frequency in descending order. Okay, so this in Cypher is pretty intuitive. When you look at a query, everything makes sense, while in the SQL, I mean, it still makes sense, especially if you are a relational database user, but as you can see, the query gets really complicated, and this maybe is telling you that you should consider using graph databases. Okay, so as I already told you, I will let you know a couple of examples of when to use graph database, and then maybe you will also think of your examples and maybe play a bit with the graph database. So social networks are a really popular example. As you know, lots of social networks have a lot of highly connected data, because we have a situation where some user is a friend with another user that is a friend of another user and so on. So why is this even useful that it is stored in graph database? It is useful because you can run different kind of graph algorithms on this kind of data. For example, you can run community detection algorithms and determine the communities inside this kind of networks. You can also generate different kinds of link predictions. In that way, you can recommend one user to be friends with another user, and so on. Another example that is pretty common are recommendation engines. For example, here we have a graph of movies that are of some genre and users that rated some movies, and I'm going to show you that later on in the code part. So here we can determine similar users based on the movies they rated, and then in the end recommend a new movie to some user. Supply chain management is some kind of business example where you can, for example, find weak links in these kind of networks. This means that if you find out that some raw supplier didn't deliver some goods to the supplier, what would actually happen? You can do different kind of business risk analysis. Fraud detection is probably very popular. It's very popular graph use case. This here on the image is actually card fraud detection. What you can do with it, with different kinds of graph traversals, you can track from where the fraud originated from. You can also, with the community detection algorithms, determine different kinds of groups of fraudsters that are working together. So this is especially interesting. It gets interesting when you have streaming data, and then you can run this kind of analytics with dynamic algorithms, and you get the results pretty fast. This image is showing, actually, this is a black background, and the highlighted things are nodes and relationships between the users of Facebook. So actually you can see how it draws the whole map of the world, because everyone in the world is connected with Facebook. So this is a really interesting photo. Okay, now let me tell you a bit more about Memgraph. We need to first learn what it is in order to use it with Python, of course. So a bit about Memgraph. It is a platform for graph computation on streaming data, and it is powered by an in-memory graph database. This database is actually implemented in C++, but we allow you to create a different kind of modules, procedures in Python, which is familiar for you, and we also have a Python client called GQLAlchemy. I will talk a bit about it in the next slide. So Memgraph is used to store graph data in memory. It is used to run graph analytics, and it's used to analyze streaming data. So this is the whole ecosystem. So Memgraph is just this middle puzzle. It is just a database, but around it we built like a whole bunch of clients. We built MAGE. This is a graph analytics library in Python, also in C, C++, and Rust. We also built Kafka, Pulsar, and Redpanda connectors, consumers inside of the database. So actually you can connect to stream of data and analyze it as it comes to your database. We also have a lab, Memgraph Lab. This is a visual user interface. So a bit more about GQLAlchemy. GQLAlchemy is a fully open source Python library. It is an object graph mapper. That means that it is a link between graph database objects and Python objects. So if you ever use the SQLAlchemy for relational databases, this is the same, just it is for like SQLAlchemy for graph databases. It includes like OGM capabilities, query builders. So this is something, if you are not familiar with Cypher query language, then you can use Python code. Also, it has on-disk storage that allows you to seamlessly save some of your properties on disk. Also, since we have object graph mapper, we allow you to define different kind of restrictions for graph schema and constraints for graph schema validation. So I mentioned a bit about a couple of things about graph algorithms on the different graph use cases. So what are actually graph analytics? So graph analytics, also called network analysis, generate insights hidden in the relationships of the network structure. Some of the most common algorithms are clustering and community detection, connected components, PageRank, shortest path, BFS, and DFS. Maybe you heard of some graph algorithms that are being used now by some of the most familiar companies, such as Google. Google has built PageRank algorithm for the ranking of search results. Facebook is using community detection as well as other social networks. Amazon uses collaborative filtering for recommendations. Pinterest uses random walks and graph machine learning also for some kind of recommendations. Uber Eats uses graph machine learning and so on. So graph analytics are pretty popular, especially in big companies that find value in relationships between users, nodes, finding similarities between them, and this is where the true power of graphs and graph analytics is seen. So MAGE is something that we created as a part of our ecosystem. So it is Memgraph Advanced Graph Extensions. This is an open source repository that has all user-defined graph analytics modules and procedures. This actually extends Cypher query language. So as I mentioned, whenever you don't have something that you want from Cypher, you can implement it as a query module. That is as a procedure in Python, C, C++, or Rust. And also we have prepared a set of graph algorithms such as PageRank, betweenness centrality, community detection, and so on. And these kind of algorithms are called just like functions inside Cypher query. So it's easy to use. I will show you how to use it. And it's really good that you have a set of these algorithms already prepared, so you don't have to think about their implementation. So whether they are implemented in C++ and maybe you're a Python developer, you don't have to think about it. You just have to like call it, and that's it. So it's pretty easy to use it. Besides traditional like static graph algorithms, it also implements dynamic graph algorithms. This means, for example, if you have dynamic PageRank algorithm, that once the new data comes to the database, once the new data streams into the database, new PageRank values will be calculated on that node and locally around it. They will be approximated and then propagated through the whole graph. So this is kind of a different approach, and it depends whether you have static or streaming data. So that's it for the beginning. Now let's do some coding. I'm going to show you how to connect to Memgraph and how to define a schema inside your Python code, how we are going to import a dataset, and how we are going to explore it. Okay, so the next step was for us to do some coding. I'm going to show you throughout this tutorial how to create a graph model from a dataset, how to run Memgraph with Docker, how to connect it from a Jupyter Notebook with the help of GQLAlchemy, and how to perform simple queries. Here we will explore the movies dataset, which has two CSV files, movies.csv and ratings.csv, but I'm going to show you how that looks like. Okay, let me just make this a bit bigger so that you can see it. Okay, so what you need to have in order to run this, you're going to see All the links here also attached, because everything here, this is a public Jupyter Notebook, so you'll be able to see it afterwards. And the requirements is for you to have a Jupyter Notebook, for you to have Docker. We are going to use Docker to run Memgraph. CMake, which is a prerequisite for GQLAlchemy, and the Memgraph platform, which means that you need to pull the image locally, called Memgraph platform. This image contains Memgraph database, Memgraph Lab as a visual user interface that will be running at localhost 3000, MG console command line interface for running queries, which we are not going to use in this tutorial, but you can try it out. And also MAGE, which is a graph algorithms and modules library. Okay, so first what we need to do, if you have all the prerequisites, if you don't, please pause this video and download it all. If you do have, you can continue with this video. Okay, so first we need to run Memgraph platform image as noted here. We are going to run, so currently while I'm filming this, the newest version is Memgraph platform 2.4.0, so we are going to use that one. Here we have defined, if you are familiar with Docker, if not, I'm going to explain it. So we have 3 ports here that we binded. So this is 7687, this is for Memgraph to communicate via bolt protocol. 7444 is for Memgraph logs that are going to be shown in the Memgraph Lab. If something goes wrong, you can see what's up. And then we have 3000, which is there for Memgraph Lab to run on. Okay, so next, another thing which you need to install is using pip. You can install GQLAlchemy and pandas library. Pandas library not necessary. I'm only going to use it in 2 code lines just to show you how the dataset looks like. If you don't want, you don't have to install it. GQLAlchemy, I'm going to mention, I think, version later on, but I'm going to use 1.3.2. So if you don't have it, you can install it now, or you can wait until we get to that part and then pause the video and install it. But for now, let's first run Memgraph. I'm going to show you how to run it. Like, you just copy this Docker command, open up a terminal, and as you can see, I have already typed this in, and I just press enter and run it. Okay, so now it says that Memgraph Lab is running at localhost 3000, and we have this command line interface. This here is MG console, as I mentioned before. This can be used for querying the simple Cypher data, Cypher queries. So for example, let's do a simple query of match and return count. And what this does, it finds all the nodes in the database and gives me back the count of how many nodes there is in the database. Okay. So we get that there is a 0 nodes. Okay, so here it's a bit like you get this table. It's not that pretty, but with Jupyter Notebook and Memgraph Lab, we can get something much more prettier. So let's head over to the localhost 3000. And here, this is like the main front screen of Memgraph Lab, and you can just click to connect now because everything it's running. It notices that you have running Memgraph instance. Okay, so now first let's head over to the query execution, and we can type our query here. So let's go again, match and return count n, and let's run it. And it says 0. So there is a 0 nodes in our database. As you can see also on the counter above, we have 0 nodes and 0 relationships. So there is currently nothing in our database. Okay, this is just so that you can see that our Memgraph instance is running and that we are connected to it. Okay, let's see what is the data set that we are going to work with. So first we have movies.csv, and it's located currently in my data folder, and you can also find it on GitHub in this repository, also in the data folder. Let me just show you what this repository is consisted of. So we are in the GQLAlchemy workshop repository, and we just said, okay, let's see what's there. So we have workshop. This is where this notebook is located. We have solutions. This is the notebook with solutions to the exercises and assignments I'm going to give you so that you can check whether you solved them correctly. And some other data. Image is just something that I needed to show in the notebook, readme, requirements, just simple things that you need to be able to run this. And if we go to the data directory, then we can see that we have movies and ratings.csv. Okay, so this is great. We are going to, with pandas, just read the head of this movies CSV file and check out what's out there. So we have some kind of table, and this table consists of 3 headers called movie ID, title, and genres. So movie ID is like a simple number, title is some kind of string of, that's the name of the film. We have genres. These are some kind of genres that are delimited with pipe. So actually we are going to have to solve this in some way, but we'll see about that later on. So this is a pretty common data set. I would say it's pretty intuitive what it is about. But we have another CSV file. It's called ratings.csv. This data set says, okay, we have some user with some ID. So our user only has this ID. And this is some kind of records of which movies some kind of user rated. So if you ever dealt with relational databases, that's actually it. So you have this kind of table, and this is what tells you what happened, and you have this stored, and that's it. But now we are going to use graph databases to make the most out of it, and you're going to see what happens. Okay, so first, like, what's my mindset? What do I have to do first? I first have to draw something. I have to draw a graph data model. So from these tables, like CSV files, what makes sense? Like, what can I create? So I have a movie. Each movie has a genre. I mean, one movie can have more than one genre, as you can see. Okay, and then I have users. Okay, and these users rated a movie. Okay, so what I can do is something like what I did here. So I have a user that rated a movie, and I have a movie that is of some genre. Now you can model the data however you like, but it depends on what you want to do later on. So if I want to know which movie is most rated one, it's good that I have this rated relationship. Also, if I want to know how many comedies there are, it's good to have genre node, so node labeled with genre. So this is kind of just a simple data model that makes more sense for me. So I have a data that is labeled with user, genre, and movie, and I have properties on movie ID, title. I have properties on user ID, on genre, name, and also I have relationships of types rated and of genre, and this rated has also properties called rating and timestamp. So it depends on what rate the user gave to the certain movie and when. This when part can be useful sometimes if you want to, like, I don't know, give to the user their own personal, like, how many movies did you rate in 1 month or so on. So you can do that kind of analysis. Okay, so let's head over to this part. We draw everything, and now we want to put it in our database, and all that we have are these CSV files. And we want to do it with Python, and we want to do it quickly. We want to make it as neat as possible. So I'm going to use GQLAlchemy. GQLAlchemy, as I mentioned, is an object graph mapper that we use to connect with Memgraph and quickly execute some kind of Cypher queries, but using Python. Okay, so now if you still haven't, pause the video, run pip install GQLAlchemy 1.3.0. This is the one that I'm using now. If you decide to do otherwise, please just follow our documentation to make sure that everything works correctly. And if you still haven't, and if something's going wrong, just install CMake before installing GQLAlchemy. Okay, now we can jump over to the connecting to Memgraph part. So first we need to import Memgraph, like this is like an object that actually holds the connection to the Memgraph from GQLAlchemy. Next we are telling it that it's running at localhost 7687. This is what we set up with our Docker container. We told the Docker that it runs on 7687. And now we are just to be sure, but we know that there is nothing in the database because we already checked it. But okay, you can run this kind of procedure called drop database. This is something that is implemented inside GQLAlchemy. And what this actually does in the background, it runs the Cypher query that is like match and detach delete n, and this query means okay, delete everything in the database. So what we actually created is a wrapper around these Cypher queries that allows you to just run this simple Python code. Of course, this is something that is a work in progress, so like the more contributors we have, the better the GQLAlchemy is going to be, and it's an open source project, so feel free to contribute whenever you like. Okay, now let's run again that query that checks how many nodes there is in a database. I know that it's already boring, but we can do it also with GQLAlchemy. We have this method that is called execute and fetch. And this method allows us to run Cypher query with inside our Python code. It's not like ideal because it's not with Query Builder. You can do it like that. I'm going to show you. But this is just running simple Cypher query with using GQLAlchemy as a simple client. Okay, let's do it. And we get that the number of nodes is 0. Okay, let's head over now. We know that everything is empty. Everything is ready for our data to be imported. First, we are going to define some kind of graph schema in the Python code. You don't have to do that if you don't want. This is just for me to show you how you can do this and why does it make sense. So first, we should define classes that define nodes. So we are actually extending the node classes from GQLAlchemy. In that way, we are telling that the movie is some kind of label inside the database. User is also, genre is also. So next we have some kind of properties, and we define their types. And with this field part, this is actually originally from Pydantic. We are defining this schema. We are telling it if there are any constraints. So we can have uniqueness constraints, existence constraints. Uniqueness tell us, okay, there shouldn't be any other user with the same ID. Exists tell us that there shouldn't be any user that doesn't have an ID. And also index true helps us with loading the data because we decided to index all the users. So whenever something merges with user or something else, then it gets a lot faster with these kind of indexes on ID. So sorry, I'm talking about a movie. I'm talking about a user, but same goes for the movie. So actually, yeah, it's the same for the movie and from the users. And these IDs are very special because when loading, they are going to connect to each other. And that's why it makes sense to have these indexes. Okay, next we are having title property. On user we have ID and name. On genre we have name. And then we head over to the relationships. Relationships have type. Why we are having type here and not like labels with nodes? Because nodes, so if we don't give them argument labels, then they take a class name as labels. And since like the casing in usually in graph databases is like this, then we leave it like that. But with relationships, I want the uppercase because it's like a convention to use it in uppercase. So that's why I gave it this another argument called type. So we have rated and we have off-genre types of relationships. Okay, now I run this and I've defined the schema inside the database. Okay, but how I'm going to even check this? Do you believe me that this is here? Let's try to do something. So here is how we are going to create and return nodes and relationships. So let's create something simple. I'm going to create a user node that's me, like Katarina. I'm going to give it name Katarina, ID 1, and movie node. This movie, let it be Lotter, so it's like Lord of the Rings, hopefully you know. And then I just run .save and movie node.save. So this is also a procedure from GQLAlchemy that allows you to easily save nodes into the graph database. Let's do this. Okay, so I just printed this user and movie node, but I want to know, I guess they are in the database. Okay, let's check. So when you print it, you can see that this is actually an instance of user and movie class. Okay, that's great. Then we have this properties key, and it has this value, ID, makes sense, but what is this first ID? So this is actually internal Memgraph ID that creates IDs for each object, graph object, whether it's node or relationship. And you're going to notice these IDs. So internal ID is not necessarily the same thing as property which you define as an ID. So you have to be careful about those. Remember this if you get stuck somewhere. So let's head over to the Memgraph Lab. As you can see, there is 2 nodes. Let's run this query again. Okay, it's 2. Let's see what's inside the database. So I'm going to run match and return n, and I get all the nodes. So first, this is like this because we have something that is called Graph Style Editor, and with this, this is a language similar to CSS. You can like change your look of your graph. So you can like add here. We said if it has name, then it is like written here. So that's why Katarina is written like this, and movie there has no name because no movie has property called title. So let's add this here and apply it. Okay, now both movie and user nodes have like their name attached to it. Also, color depends on the label. Let's see. Okay, Katarina has ID and name. This has ID and title. I guess everything looks right? But we don't have any relationship between them. We're going to create that. But first, let me show you why I did that schema. Why did I even create it? So if I try to create another user that is also called Katarina, and remember, I put a uniqueness constraint to name, I accept and I expect this exception. So that's why it's printed a user with the name Katarina already exists in the database. So wondering whether it's created, actually no. So user with username Katarina will never be created again. And this is great if you have a lot of data coming in and you really want to make sure that everything in the database is according to the schema, then Memgraph doesn't allow you to do this if you created this kind of constraint. So that's awesome. Now let's create some kind of relationship that tells you that I created, that I rated Lotter movie. So what we do, I have this rated relationship. It needs to have arguments start node ID and end node ID, and here I'm giving it its internal IDs. These are actually those IDs from Memgraph that I mentioned before. I'm giving it in rating. I'm going to give 5 out of 5, and timestamp, I'm actually importing time from time and just giving it like now, okay, and saving it to Memgraph. Okay, awesome. Now you can see that start node ID and node ID, you can see which nodes are there, you can see that it's of type rated, and you can see the properties. Okay, let's see this in the database. So it says that there are 2 nodes and one relationship. Let's check that. So if I want to check all the nodes and all the relationships between them, I need to run something like this. So I need to run nodes, relationship, some node relationship between another node, and return those 3. So actually give me all nodes and relationships between them. Okay, that's awesome. So I have Katarina. What is this? Katarina rated. And I have rating and timestamp. So this is pretty useful. I just ran it with Python code. I said save, and I have it in the database, and I can explore my data with Memgraph Lab this easy. Okay, great. So we've done a great deal of things. I show you how to create a database. Now let's drop all we created because we are going to import the data from our CSV files. So first you need to download, or if you clone the repository, just head over to the data directory and check out the movie CSV or rating CSV files. Since Memgraph is running in Docker container, we need to copy those data inside Docker so that it can be visible to Memgraph so that we can load it. So here are the directions. If you get stuck, we also have that documented on our website. You head over to the load CSV clause, how to import data with load CSV clause on our documentation, and you have all the directions how to copy the data inside the Docker container. But this is a simple command. If you are located inside the data folder, then just run this. I'm going to show you how to do it. First, you need to figure out where is Memgraph and where is it running. So I'm going to run this. This tells me that Memgraph platform image is running here, and it has this container ID. Then, okay, I'm here, and here we have movie CSV and rating CSV. Let's copy those files inside this Docker container with this Docker ID, user container ID. Okay, so Docker CP for copy. We need movies.csv. We need to copy it here. And let's call it there inside the container, also movies.csv. Okay, next we need to do the same thing with ratings. Now it's hopefully there. If something gets stuck, I'm going to check whether it's wrong. Currently, like, it doesn't make sense for me to enter the whole container thing, but you can also see how to do that on our Memgraph docs. Okay, we are going to do this with load CSV file, and like the easiest way is just to use the whole Cypher query, because like with Query Builder, things may get complicated, and this way it's not that hard. I will show you and explain you. You'll figure it out. Okay, so we are going to load from movies.csv. This is actually looking inside the Docker container where we now copy the files. It's telling us that it has header. So it has header because, as I mentioned, it has movie ID, title, and genres. So these are the headers, and it goes row by row. Now think of it like, okay, I'm going row by row, and for each row, I'm doing something. So for each row, this query is going to create a node with label movie, and this node is going to have properties ID and title from this current row with header movie ID and title. Now I'm going to take this movie that I created, and I'm going to still take this row that I had in the beginning. I'm going to unwind. What does it mean to unwind? So we have this row of genres with the pipe as delimiter, if you remember. So I have to split those, and unwind means like put them, when you split them with this delimiter, like pipe, then like put them all in one list, and each item of that list is called genre. Now I want to create a connection between this current movie to each of its genres from this list, and this connection, that is relationship, is of type of genre. And this is what happens here. So I know maybe it's a lot, but if you like, pause it, return it, then again, or if you don't get it, you can feel free to ask me later on, but this is actually the quickest way to go. Now we did it. Let's check it, whether it's in database. So Memgraph Lab, it currently has in that wasn't even a second. It has 31,000 nodes and about 22,000 relationships. Nice. So what is it left? We need to load the ratings. So this is very similar. You can go through the query and you're going to notice that it makes sense like the first one. Okay, so we run this, and now we have 122,000 of relationships. So this is like a lot. Now let's head over back to our Jupyter Notebook, and let me show you how to do some kind of simple querying of the database and how to retrieve these results. So the simplest usage of Cypher query language is to find data that is stored in the database. You can do different kind of clauses, such as match, that searches for patterns, where for filtering match data, return for defining what will be presented to the user in the results set, and so on. You can explore that more in our Cypher manual. I think it's linked in this Jupyter Notebook. If not, you can head over to our documentation. Okay, first, we want to find a movie, and we want to return those movies by their title in ascending order. Okay, let's do that. So once we run this, everything is saved in this results variable. And then we create a list out of this results variable and we print it out. So we just limited our results to 10 results. So we have here everything from our database that makes sense in alphabetical order. Okay, now you may wonder whether this had been correctly serialized back to the defined schema. So that is awesome. Why is it called Object Graph Mapper? So we are telling it with the creating of these classes to the database that it is actually a node with a label movie or with label user. But what when the results got back to our Python code? Does the code know what that is? Does it know that it is a movie? So actually it does, and that's the beauty of it. So if I print out the movie and I want to print out the type of that variable, the type of this object that has been returned, I get that it is a movie. So anything that returns from the database, it gets serialized back into an object into the instance of that class. So this is awesome because you can run different kind of thing on this data. You can really follow your schema. You don't have to worry about those things. So feel free to try it out and play a bit with that. Okay, so now you can see that we have an instance of movie class, and we can read also its properties. So since it's an instance of that class, we can read something like m.title. Okay, so that's pretty useful. But this above was the Cypher query, and maybe you don't want to use that. As I mentioned before, we have Query Builder. So how to translate this kind of query to Query Builder? This here is created with Query Builder. So we have match, we have node, this node has label movie, and let's store that into the variable m, return all of that, order by title in ascending order, limit 10, and execute. So this is actually, you need to know like the basic constructs of Cypher, but you don't have to use all that long strings. And we get the same thing. So that's what we wanted. Okay, now let's head over to the example queries. This was just some showcase. Now let's do a couple of examples, and after each example you have an assignment. Please try to do it by yourselves. If you get stuck, you have solutions folder inside the repository. If not, but hopefully you are going to try to solve it by yourself. So good luck. Okay, so first, how you are going to find out how many users there are in the database. So what would be the correct query? You want to find all the users. This means you want to find all the nodes that are labeled with users. So we use these and say n, this is a variable name, and it is a user, and we return count of this user. This is a Cypher's function, and we are going to call this variable number of users. You can try it out in Memgraph Lab. Okay, let's do it. We run this query and we get that there is 610 users in the database. Okay, how we are going to do with the query builder? So we need to do as above, match node that is a user, return count of those users as number of users. When we print it, it's actually stored as a value of key number of users inside this dictionary. Okay, let's run it. 610 again. Awesome. Okay, first exercise for you would be to find out how many genres there are in the database. Don't worry, it's not hard. If you follow this through, it should be easy for you. If not, just head over to the solutions folder and figure it out. Okay, next, example 2. We need to find out how many users rated a movie with the title Home Alone. So, what we are actually finding, we are trying to find a path that looks like this. So we have a node user, we have a relationship between that node and another node of type rated. We have another node called movie that is labeled with movie, and this movie has a title Home Alone. And we want to return the number of users that rated movie Home Alone, and we actually return count U. So yeah, it actually is pretty like, as I'm telling you like this, like with normal language, it actually translates to the Cypher query. Okay, next, you can try it out in Memgraph Lab. Let's do that. So it says 116. Awesome. Now let's do that same with the query builder. It's again the same. So you match node to node. So here we have a relationship and we use it like this. Then we have where, because we have this property, and we can do it also with where clause. So we have where title is Home Alone, and let's return count U as number of users. Great, it's again 116. For you to try, you can find out how many genres the movie matrix is connected to. It's not that hard, it's pretty similar, just try it. Third exercise is to find the genres the movie Blue Lagoon is connected to. Okay, so we need to find a movie that has a title Blue Lagoon, and it is of some genre. And what is that genre? Return me this name of this genre, and that's it. We can try it out in Memgraph Lab. Okay, so Blue Lagoon is, I guess, not only one genre, but 3 of them. So it's an adventure, a drama, and a romance. Awesome, we can do this also with Query Builder. So it's just similar as above. We match node to node, where title of a movie is called Blue Lagoon, and return the name of this genre. Just be careful to use these variable names as it's written above, so you don't get messed up with the return clauses. Okay, so it's adventure, drama, and romance. For you to exercise, please find out the title of the movies that the user with the ID 1 rated. Good luck. Next, we are going to try to list 10 movies of comedy and action genres and sort them by title. So, what we need to do? We need to match movie that is of genre, and this genre is action, but also give me that same movie that is also of genre comedy, and in the end, give me the title of that movie, and let's sort them by title. When there is no order, like there is no descending or ascending, then it is descending. And limit 10. Okay, same we do with Query Builder. This is, we can just first try this in the Memgraph Lab. Okay, we get this. And then if we try with Memgraph Lab, we tried with Memgraph Lab, now we try with Query Builder. It's actually the same, it just gets a bit more complicated because of the more queries we have here. Is there something new? I guess not. So we again have node to node where, then again you have to do match because we again have the match clause, node to node where, then return the movie and order by title and limit 10. Again, we get the same result as in Memgraph Lab. For you to exercise, please list 15 movies that are of documentary and comedy genres and sort them by title descending. Okay, now example 5, I think this is the last example, not sure. Find out the average rating of the movie Star Wars Episode 4, A New Hope. Here we have to use Cypher function. So we already used the function called count. Here we have to use the function called average. So it's not hard. You just have to see the list in Cypher manual of all of our clauses and of all of our functions in Cypher, and you can use them. So this correct Cypher query will be match user that rated a movie, and the title of this movie is called Star Wars Episode 4 A New Hope. And then just return the average rating of this relationship of type rated. So don't be confused. Remember that our relationship of type rated has property called rating, and that's why it's r.rating. Let's try it out in Memgraph Lab. Okay, so it's 4.2. That's pretty okay from out of 5. I would maybe give it a more, but I guess it's fine. Then we do it again with the query builder in the same way. Just don't forget that you have to, in the return clause, put average as a function, and you just use it as a part of a Cypher query. This can be maybe in Python, in Query Builder, implemented a bit nicer, but we will have to import all of our functions that are existent in the Cypher query language, and that would be like maybe in one of the next editions of GQLAlchemy. Okay, let's print it out. 4.23. I guess that's good enough. Now for you, find out the minimum rating of the movie Star Wars Episode 1, The Phantom Menace. It's similar to that, but yeah, play with it. You can also find out who has like the worst rating and so on. Okay, now if you want to know more, I'm just going to go through these little examples and you can later on read more about it. I'm just going to tell you what else you can do with this kind of data set to play with. So you can, for example, create some kind of simple movie recommender. This is nothing like too smart. This is just simple memory-based collaborative filtering query. It uses user rating data to compute a similarity between users or items. So actually here in this clause, this collaborative filtering is used. And then in the end, if I run this query, I get the actual recommendations for the user, as you can see, with the ID 608. So you can go through this query and maybe explore it a bit more. I actually wrote here a bit of description where it goes, where we dive into the details of this query, but this is something maybe if you are more interested in graph analytics and not in the actual Python client, so feel free to check it out. Also, you can play with some other parameters. You can use different kind of similarity functions. For example, here you have an example of how would you use an Euclidean distance. So the similarity from above that is here would actually be defined a bit different with a square root and so on. But yeah, you can play with it however you like. It depends on whether this is whether this is your use case. But maybe more interesting example, and maybe something that we like to talk about more is graph analytics. So graph analytics, as I mentioned, we have a different set of graph algorithms inside Memgraph that is inside Memgraph Advanced Graph and Extensions library called MAGE. And I'm going to show you how to perform PageRank algorithm. This algorithm will determine like the most influential node inside our database. So it depends what is your data set. If you have something like, we had some example of Game of Thrones kills data set, so then like the most influential node would be the best killer. So it's not exactly something positive. So you need to think about your data set and graph data model in order to know what these results exactly mean. So here I would just say the most influential node is actually the one that has the most user rated. So it doesn't have to necessarily be the best rating, but it's like the most rated movie. Okay, so we have this procedure. As I said, these procedures extend Cypher query language, so we just call it like this. This PageRank is a query module. PageRank is the query module, and get is the procedure from that module. We return everything back. We have actually something that is called node and a rank. We filter this by movie nodes because we want to find the most influential movie, and we get those titles, and we order by rank descending because we want to first see like the best movie and just limit it to first 50 results. Okay, let's run this in Memgraph Lab. And we get this. So what is this? This is actually Shawshank Redemption. Here you can see like this number is always going to be between 0 and 1 because it's some kind of probability. And I mean, this pretty much makes sense for me. I mean, I know it doesn't have to be the best movies, but I guess by IMDb or something like that, it's Shawshank Redemption is like the first movie. So I guess in this data set that we have, sample data set, it's also the most rated movie. So I guess it will make sense if you maybe decide to check it out. Is it the best rated movie in the data set? I'll let you get to it. But yeah, we can also run this with query builders so that it makes your life easier. And as you can see, we just call this with the call procedure. And everything else is what you are familiar with the in the above queries, and we get, of course, the same results. Okay, so that's it. Hopefully you gain new knowledge with this workshop. You enjoyed it. If you have any questions, please don't hesitate to contact me directly or join our Discord server. As I said, you have solutions to the exercises that I gave as assignments in the solutions directory, so feel free to head over there if you get stuck, and good luck with solving all those assignments. Let me just finish now the presentation that I had. So what we learned how to use graph databases when the data is highly connected and when we have lots of many-to-many relationships. We learned that Memgraph is a platform for graph computation and streaming data powered by an in-memory graph database. We learned how to create a graph model. We learned that the easiest way to import data is using the load CSV Cypher clause. We learned how to use GQLAlchemy. And we learned how to perform graph algorithms such as PageRank. In the same way, you can perform different kind of algorithms and play with this data set. Thank you very much again for your attention. Hopefully you like this course. And if you like what we do, please throw us a star. We are an open source project, so feel free to throw a star to Memgraph or GQLAlchemy. If you are keen to open source contribution, feel free to contribute to GQLAlchemy or MAGE. These are both Python libraries, so it may be easy for you to head over there and maybe contribute in some way. Also, as I mentioned, we have a Discord server. This is a pretty good place for Python developers. So we are trying to make as many courses and materials as we can for Python developers. So let us know what you think about Memgraph, about GQLAlchemy, and if you decide to create something by yourself, please share with us. Thank you very much for your attention, and hopefully hear from you soon.